So this video is for lesson 2 of our trigonometry unit. Today we're going to focus on cofunctions and equivalent ratios. So there's two main goals we need to get out of this. Number one is to determine if two trig ratios are in fact cofunction equivalents, and then also to solve for a missing variable that's going to make two trig functions cofunction equivalents. Okay? Oops. So for the warm-up, we want to review finding our trig ratios. So first, if I focus on the sine, cosine, and tangent from angle R, I want to circle or put a mark on angle R and label my three sides. The hypotenuse is always across from the right angle. My opposite side that's across from angle R, in this case, is 15, and the adjacent side right next to it is 8. So when I want to find the sine of angle R, I want O over H, or 15 over 17. The cosine of R is going to be A over H, or 8 over 17. And the tangent ratio for angle R is going to be opposite over adjacent, so 15 over 8. Now if I go to repeat the same thing, finding the sine, cosine, and tangent ratios for angle S, I want to mark angle S as my angle of reference and label my sides. So my hypotenuse is still the same across from the right angle, but this time the opposite side across from angle S is going to be 8, and the adjacent side next to angle S is 15. So when I do the sine ratio for angle S, O over H is going to be 8 over 17. My cosine ratio, A over H, is going to be 15 over 17, and the tangent ratio for S, O over A, would be 8 over 15. So notice what happens here when our opposite and adjacent flip. My sine ratio for angle R is the same as the cosine ratio for angle S. Likewise, my sine ratio for angle S is equal to the cosine ratio of angle R. So that brings up very important properties that we're going to talk about today. So when we have a right triangle, we know that one angle has to be 90 degrees. That's what makes it a right triangle. So we know all triangles, the three angles add up to 180 degrees. So if I take away 90, there's 90 degrees left. That means that your other two angles that we have will always have to add up to 90 degrees. And when two angles add up to 90 degrees, we call that complementary. Okay, so that's what creates our cofunction equivalence. So that co prefix in front of cosine means that it's a cofunction for sine when the angles are complementary. So in other words, this is what we need to know here. Your sine and cosine ratios are equal when the two angles add up to 90. Now this is just notational things here. Sine of theta equals cosine of 90 minus theta. This is just a fancy representation of saying that two angles add up to 90. So theta here is a Greek letter that just represents a variable. It's just like x, but instead of x, we use this Greek letter theta. Okay, so this is some unknown. 90 minus that unknown is a fancy way of saying that the angles add up to 90 degrees. We're going to get more practice with that type of notation next time. Okay, but for now, let's go back to our two goals for today. Goal number one is to figure out if these statements are true or false, to determine if we actually have equivalent cofunctions. So in order to have cofunction equivalence, your first criteria is that you need to have one as a cosine function and one as a sine function. In example 1, here's cosine, and here's sine. Now my two angle measures, 78 and 12, do in fact add up to 90. So this statement is true. I have sine and cosine ratio, and my two angles add up to 90. So that's what it means to be true, to have equivalent cofunctions. In example 2, sine of 55 equals cosine of 25. I have a sine ratio and a cosine ratio, so I satisfy that criteria. Now when I look at my two angle measures, 55 and 25, if I add those together, I actually get 80. So even though I have a sine and cosine ratio, my two angles don't add up to 90. So this statement is false. They're not going to be equivalent. In example 3, I have the sine of 89 degrees equals the sine of 1 degree. Right off the bat, we can clearly see 89 and 1 are going to add up to 90 degrees. But notice I have a sine function saying it's equivalent to another sine function. Remember, in order for these to be equivalents, I need one sine and one cosine. So that's why example 3 is also false. Okay, so in your Google slide assignment, you're going to have 3 of these true or false questions to evaluate on your own. Okay, goal number 2 for today was to figure out a missing variable that's going to make each statement true. So in other words, we're trying to solve for x or theta. So in example 4, I have sine of theta equals cosine of 25. I have a sine and a cosine ratio saying that they're equal. In order for that to happen, I need my two angles, in this case theta and 25, to add up to 90. So all of these types of questions are going to come back to a part plus part equals 90 situation. So theta plus 25 equals 90. Okay, so that's what gives me theta equals 65. Tried to show out all that work. Okay, when I look at example 5, I have the sine of theta minus 45 equals cosine of theta. So in order to make that statement true, my sine and cosine ratios to be equal, that means my two angles, theta minus 45 and theta, have to add up to 90. So I want to say part plus part equals 90. So theta minus 45 plus theta equals 90. Now remember, theta is just like x, so I want to combine those as like terms. I have 2 theta minus 45 equals 90. Add 45 to each side, divide by 2, and we get theta equals 67.5. Okay, so when you do your questions in the Google Slides, just know you don't have to type out all this algebra. I just wanted to show out the work for you guys. As long as you can tell me your final answer, that's fine. Okay, last guided example. Again, goal 2 for today, finding the variable, the value of the variable that's going to make this statement true. So for a cosine and sine ratio to be equal, my two angles, 3 theta minus 6 and theta plus 8, have to add up to 90. So again, part plus part equals 90. Again, we're just cranking through the algebra just like you would solve for x. I tried to show out all that work here, and we get theta equals 22. So the geometry part is recognizing that your two angles have to be part plus part equals 90, and then the algebra part is just cranking that straight through. So once again, you're going to have 3 examples to try on your own in your slide assignment. Again, you don't have to type out the entire algebra process, but I just need you to at least give me your final answer, x equals whatever. Please let me know if you have any questions. You can email me, call or text me, or if you want to set up a video chat, we can do something as well. Just let me know.